All right, so in this video, we are going over Notes 1, Section 9.1, which is adding, subtracting polynomials. And we're also going to talk about naming polynomials and what polynomials are and the different types of polynomials. So let's start off with some vocab first. So first vocab word, a monomial. So a monomial is an expression that is a number, a variable, or a product of a number and one or more variables, okay? So let's go through a couple examples. 12. 12 is a number, so it's a monomial. It is not being added or subtracted anything, so therefore it's a monomial. Y. Y is a single variable. Again, not being added or subtracted to anything, therefore it's one term, which is mono. Mono means one. So it has one term, which means it's a monomial. Negative 5x squared times y. So because negative 5 is being multiplied to x squared and to y, it is considered a monomial. If it were being added, so if negative 5 plus x squared plus y, that would not be a monomial. But again, because it's the product, meaning multiplication, of a number and one or more variables, it is a monomial, okay? So here's another example. C divided by 3 or C over 3. Again, monomial because the operation between the two is division, not addition or subtraction. So if we are adding and subtracting terms, it becomes a different type of polynomial. Let's talk about the degree of a monomial. What does degree mean? So the degree of a monomial is the sum of its exponents of its variables. So you only take the sum, which means you add the exponents of just the variables together. So in this first example, we have 2/3 x with no exponent. Well, we know that when we don't have an exponent listed, our exponent is 1, so therefore our degree is 1 because x is our only variable. Second example, 7x squared times y cubed. So we look at just the variables, we take their exponents, and we add them, so we get a degree of 5. Third example, we have negative 4. There is no variable, which means the exponent is 0, so the degree is 0. Again, there's no variable, so you can't have an exponent there. So what is a polynomial? A polynomial is a monomial, or the sum or difference, meaning addition and subtraction, of two or more monomials. Okay, so for example, we have 3x to the fourth equals 5x squared minus 7x plus 1. This is a polynomial. It consists of many monomials. Well, poly means many. So 5x squared is a monomial. Negative 7x is a monomial. 1 is a monomial. But because we're adding and subtracting these together, the sum or difference of one or more monomials, it becomes a polynomial. It becomes a term with many terms. It becomes an equation with many terms called a polynomial. Standard form. So there's different ways we can write our polynomials, okay? Standard form of a polynomial means that the degrees of its monomial terms decrease from left to right. So you got to start with the highest exponent and work your way down to the lowest exponent. And we'll talk about what that means here in a minute. The degree of a polynomial. Okay, so kind of similar to the degree of a monomial, all right? But we're talking the degree of a polynomial in one variable, all right? So the degree of the polynomial in one variable is the same as the degree of the monomial with the greatest exponent. So the degree of the polynomial is the same as the degree of the monomial, right? So we find it the same way. But it's the degree of the monomial with the highest exponent. So let's look back up here where we have this 3x to the fourth equals 5x squared minus 7x plus 1. Let's just look at this half right here. all right? So remember when we said 5x squared, negative 7x, and 1 are each different monomials, but together they make a polynomial. Well, the degree of the polynomial is the same as the degree with the highest exponent for the monomial. So because these are all different monomials, we take the highest exponent. Well, 2, 1, and the degree of this guy is going to be 0 because there's no variable, no exponent. So the degree of this polynomial is going to be 2 because 2 is the highest degree that you have between these three monomials. Okay? So now let's get into some more key concepts here. In the table at the bottom, we have our different types of polynomials. We're talking about degrees. We're going to name them. We're talking about their number of terms that they have. And then we're going to name them using the number of terms they have as well. So let's go through this one by one. These are the different types of polynomials we have. So the first example, we have 7x plus 4. Its degree is 1 because what's the exponent on x? The exponent on x is 1, which gives you the polynomial degree of 1. All right? Go ahead and erase that. Name using the degree. Because it has a degree of 1, that is called linear. All right? That looks like equations we have graphed before back in chapter 5 and chapter 6. We graphed a linear equations. All right? So that's where that comes from. In this polynomial, we have two terms. We have 7x and 4, which is why, under the terms column, we have 2. And when we have two terms, that's called a binomial. All right? I have a highlighted because these are all very important. Oh, I should highlight monomial as well. That is a vocab word that we've been talking about. All right? So monomial, binomial, and trinomial. So mono means 1. Bi means 2. So binomial. Trinomial means 3. So tri means 3. And you can see that our second polynomial has 3 terms, which is called a trinomial. Okay? So the next one, we have 3x squared plus 2x plus 1. The degree of the polynomial is 2 because that's the highest exponent. The name of this is called a quadratic. So when you have a degree of 2 or an exponent of 2, it's called a quadratic. It has 3 terms. It has 3x squared plus 2x plus 1. Again, see how I'm emphasizing the word plus? Because we're adding these terms together. We're not multiplying. And when you add these terms together, they're individual terms at that point. And again, like I said, it becomes a trinomial. Okay? Third one, 4x cubed. The degree, what's the exponent? 3. It's called a cubic. All right? And this only has one term. So that 4x cubed is just one term. Again, 4 and x cubed are not separate terms because they're being multiplied together. So it stays as one term, which again is a monomial. We have 9x to the 4th plus 11x. The degree is 4 because it's the highest exponent. This is just called a 4th degree. All right? So anything after a cubic just becomes 4th degree, 5th degree, 6th degree, 7th degree. You just name it by whatever the number is. It has 2 terms in this polynomial, and it's called a binomial. All right. Last one, just the number 5. What is the degree? The degree is 0 because there's no variable. This is called a constant. Okay, so think of the word variable. Variable means vary. It means it's going to change. It means it doesn't have a set value, right? 5 will never change. It will always be 5. It will always stay constant, all right? It is one term, therefore it's called a monomial. All right, now on to the back. Now we're going to talk more about adding and subtracting polynomials. So let's start off with adding polynomials. There are two ways. To solve, okay? Whichever way works best for you is what I want you to use. So if you like it vertically and you like lining it up vertically like we do longhand addition or subtraction, do that. If you like writing it horizontally and you can kind of see the common terms, go ahead and do it that way. Either way, as you can see, we get to the same solution. So I'm going to go ahead and explain both. And then I want you to use what works best for you. So up at the top, 4x squared plus 6x plus 7, all in parentheses, plus 2x squared minus 9x plus 1. We're going to add this polynomial to this polynomial, all right? In other words, guys, we're combining like terms. So make sure when you're combining like terms, x squareds go with x squareds. X's go with x's and constants go with constants. I can't add 4x squared plus negative 9x. X squared and x do not go together, all right? So that's why you can kind of jump over here and see if you want to solve it horizontally and you want to write it out long way. See how I highlighted in colors here? They're like terms. It's because you have to keep their like terms together, all right? So let's finish this example and then we'll hop back over to the vertical example. The operation in the middle is addition. So all you're going to do is take the first term. We have 4x squared plus positive 2x squared. Well, 4 plus 2 is 6, and keep the x squared the same. Then we have 6x plus negative 9x. So 6 plus negative 9 gives us negative 3, and keep the x the same. 7 plus positive 1, gives you 8, and you're done. Okay? Now, if you don't like writing it out horizontally and you like writing it vertically better, hey, you do you. Just make sure when you line it up vertically that you're lining up your common terms together. So let's say this wasn't in standard form, or it wasn't in the same order, like if we had these two terms switched or something like that. Make sure you line it up according to their like terms. All right. And then if you have to switch the order of your polynomial, make sure you're keeping the sign. So for example, 9x has to stay negative. So if I would move it for some reason over to the other side, make sure you take that negative with it. Otherwise you're changing the value of it and you're not going to get the correct answer. So same thing, 4x squared plus 2x squared, add the coefficients, keep the variable the same. So then you have 6x plus negative 9x, which gives you negative 3x, and 7 plus positive 1, you get 8. All right, and then example 2, subtracting. Same idea, but this time you got to be careful because you're subtracting the second polynomial. So it's always important to start with the first polynomial and then keep the second polynomial second, so that way you're subtracting in the proper order. All right, so again, we're going to start with method 2 and then hop back over to method 1. So method 2, 2x cubed plus 5x squared minus 3x minus x cubed minus 8x squared plus 11. You want to go ahead and distribute that negative so that way you can write it without parentheses, because otherwise you have to remember to go back and constantly subtract. Now, you can kind of see right here that we're going to have a double negative. So I would have to do 5x squared minus negative 8x squared. You're getting that double negative, which means adding. Okay, so if you want to add in that extra step there, it's not going to hurt you. It's just going to take a little extra time. But when you distribute that negative, you're going to get 2x cubed plus 5x squared minus 3x minus x cubed plus 8x squared minus 11. Right? So again, you can see I color-coded it. We've got 2x cubed and we've got negative x cubed. 2 minus 1 gives us 1x cubed. We have an x squared and x squared, so let's combine. We have 5x squared plus 8x squared gives us 13x squared. I don't have anything to combine my negative 3x, so it stays as is. Same thing with my negative 11. Stays as is because I have nothing to add or subtract it to. All right? So this is another way that you can set up your subtraction problem. And again, this is kind of showing you that if you don't have a common term there, you can either put a 0 or you can leave it blank and just bring it straight down. So we've got our 2x cubed plus 5x squared minus 3x. And then subtract x cubed minus 8x squared plus 11. But you see how I distributed and I changed my sign so that way it was easier. When you distribute, guys, that means then you add. So I would be doing 2x cubed plus negative 1x cubed, which gives me my 1x cubed. Again, 5x squared plus 8x squared gives me 13x squared. Negative 3x, I have nothing to combine it with because I don't have another x term. So it stays as negative 3x. And then same thing with my 11. I have nothing to combine it with, but remember, because I distributed my negative, it becomes negative 11 now. If this does not make sense to you, don't do it this way. It's okay to pick this method instead. Okay? So that's notes on section 9.1. If you have a question, please email me and check Canvas for my office hours.